Today we're going to be talking about inverse functions, and the first thing we're going to deal with is just if you have a set of ordered pairs. So we start off, you'll notice a set of the first order pair is -4, 6, and then we have 5, -3, and 9, -1. Now what you will notice, this is the inverse of those, and all we did was switch the x's and the y's from above. So the -4 that was an x became a -4y, and the 6 that was a y became a 6x. So all you're doing is flip-flopping those back and forth. Fairly simple. In the second example, 4 and 2 becomes 2, 4. 2 -9 becomes -9, 2, and 1 -5 becomes -5, 1. Pretty simple stuff. Now, determine whether each pair of functions are inverse functions, right? Yes or no. So there's a couple different ways you can do this. One is to plug it in, plug it in. So you notice what I did is I took my f of x, -3x plus 5, and I wrote it down here, but I left a parentheses where the x was, and I put the g of x, the whole thing, 3x minus 5, I put that inside the parentheses. That is where the x used to be in f of x. Okay, so we're plugging the 3x minus 5 all into there. Now when you do that, now you will distribute. -3 times 3x gives us a -9x. -3 times -5 gives us a positive 15x. Or I'm sorry, positive 15. And then we have the 5 that came along for the ride. Now we add those together, we get 15 and 5 is 20. So we get -9x plus 20. That does not work. Now, here's an example of one that does work. Okay, we've got our 7x plus 11 is our f of x. Our g of x is x minus 11 over 7. Now what I chose to do this time is I took this one here and plugged it all into, so I took this one and plugged it all into there. So I have my 7 out front, and then where the x was, I put this whole kit and caboodle. Okay, so the x minus 11 over 7. I just put the line under the whole thing here. It doesn't really matter. But then, anyway, what happens here is, oh, and the 11 came along for the ride. Plus 11, you stick off to the side. Now you cancel out the 7s. When you have a 7 on top, 7 on the bottom, remember 7 over 7 is 1, so in essence they just cancel out. So we cancel those out, and you're left with x minus 11 plus 11, just took off the parentheses, and minus 11 plus 11, they cancel each other out, and you're left with just x. When you are left with x, that is when it proves that those are inverse functions. Okay, another example. Our f of x is -1/2 x plus 3, and our g of x is -2x plus 6. Okay, so we're going to take this whole -2x plus 6, plug it in for the x. So you have the -1/2 out front, and then we have this whole g of x function goes inside the parentheses, -2x plus 6, and then the 3 came along for the ride. So you take your -1/2 x, or -1/2 times 2x, -1/2 and -2. Two negatives cancel out to become positive. 1/2 of 2 is 1, so that whole kit and caboodle just ends up being x. Then we have -1/2 times the 6. Well, what's half of 6? It's 3, and then you have to change your sign because of this negative. So we get a -3. Plus 3 came along for the ride. Then you'll notice a -3 plus 3 cancel out. So you're left with just x, so yes, that works. Okay, now finding the inverse function. Okay, now I am not going to do this, then graph the function and its inverse, so just to let you know that. Okay, so what we do is we start off with our x, our f of x equals x plus 2, and you'll notice what we do. We change this to a y. The f of x we just changed to the y because in essence that's what it is. And then what we do, if you look down here, what we did is we flip-flopped the x and the y. So we put this x goes over here, this y goes over here. We leave the plus 2 alone, and then what you do is you solve for y, meaning get everything away from y. So the only thing we have in this one is the plus 2. We take the other side, of course, it is minus 2, or you can think of it as we subtract 2 from both sides. You're left with x minus 2 equals y, so we are done at this point. You'll notice what we do down here now. The x minus 2 goes here. Then we just write it as f of x with the inverse sign. So that's inverse of f of x is x minus 2. So it's pretty simple when you just have the one thing, but we're going to get a little more complex, obviously. So this one here, we start off with g of x equals 5x minus 2. So again, we change this to a y, and then we exchange the x and the y's. Just swap places. You notice we did that here. We got an x equals 5y minus 2. Now, okay, we're solving for y, so the first thing we have to get rid of is our minus 2. So we go, uh-oh, Mr. Schmidt made a mistake here. This is supposed to be plus 2 over here. All right, anyway, ignore me, or ignore the worksheet. Just listen to me here. I will change it on the notes, but this should be a plus 2 over here. So we should have x plus 2 equals 5y, and then we divide by the 5. You'll notice you divide the whole thing by 5. So you have your x plus 2 over 5 equals y. Now we come back, we say, okay, we go back to our g of x, but now we put our inverse function there, our inverse sign, and we write down x plus 2 over 5. Now you can separate this, and in the future, maybe your college teacher will want you separated. You would put 1/5 x plus 2/5. Okay, if it's separated, but I'm not concerned with that. Now let's go to h of x, a little more complex one here. Okay, so we switch the x and the y, so we get x equals negative 2y, it was negative 2x, plus 6 over 3. All right, now we're going to multiply both sides by 3, so we get our 3x equals, and then we're just left with what we had in our numerator. Remember, numerator is a top number, denominator is a bottom number. So our numerator just stays the same, negative 2y plus 6. We will then subtract 6, so we get 3x minus 6 equals negative 2y, and then we divide by negative 2. And doggone it, I made another mistake here. There should be a negative sign in front of here. Man, getting old or something here. Divide by negative 2, this should be a negative 3/2 x, and we take our negative 6 divided by negative 2, we got 3, well at least I got that right. All right, so we will have our h of x with our inverse sign equals, and then we'll have our negative 3/2 x plus 3. I'll do better next time. Talk to you later.